And the ignition system is really very straightforward. Of course, there's problems along the way, and that's what I'm going to talk about tonight, is how to, where to look and how to sort out some problems. The ignition system starts at the battery, just like everything else in the car. So from the battery, it ends up at the key switch, sometimes to a starter solenoid where you can have a loose connection, have a problem. Ends up at the key switch. Key switches are almost always okay. Sometimes you get one that makes and breaks, and the car will start and immediately stop and immediately restart. And by filling with a key, you can diagnose that kind of problem. From there, it's almost always a straight wire right down to the coil. Beginning in 1965, we have an electric tachometer, and that white wire that goes from the key to the coil goes through a magnetic loop in the back of the tach, but then continues on down to the coil. Then on the other side of the coil, it goes to the distributor where there is a switch, originally a set of points. And when the points are closed, the circuit is complete and the coil charges up. Then when the points open, the coil, the magnetic field in the coil collapses and induces a high voltage spark, 18,000 volts, something like that, in the secondary circuit. Then from the coil, that spark travels to the center of the distributor cap, where it goes through the rotor, goes through the ignition wire, and finally gets to the spark plug. So we have two systems here, the primary ignition system and the secondary ignition system. The primary is the battery, the switch, the coil, the points, condenser. And then the secondary is the coil, the rotor, cap, and the ignition wires and the plugs. So let's talk about each one of those things in order. So down inside the ignition coil, there's a winding. So this is what's left of an ignition coil when I took it apart. Okay, so there's either 3.5 ohms of resistance in this winding, or there's about 1.5 ohms, maybe 1.5 and 3, depending on the length of the wire here. In the only weird one there is 75 through 79, and we'll talk about that in a little bit. But it's just an electromagnet, and down inside the middle of the electromagnet are pieces of iron uh, strips that fit down in the center. And then in the middle of this whole thing is the secondary coil. Now, I don't know how many turns of wire this has on it. I've never unwound it and counted. I don't know. But this has 1,500 turns for every turn that the primary does. And this wire, I don't know if I can pull a piece of it off. You can't even see it. If I put a pencil through this and someone started pulling the wire, I live on the outskirts of Grand Rapids. You could get downtown before this wire would play out. There is a lot of wire in this. So you've got a layer of windings, wax paper. Who invented wax paper? Thomas Edison, for winding coils. And then another set of windings, another wax paper, another set of windings, with about 1,500 turns more for every turn that there is on the primary. Just a transformer. And when the points are closed, it magnetizes down the middle here. And when you turn the power off by opening the points, the magnetic field collapses and it induces that 18,000 volt high tension spark in the secondary coil. Coils do go bad. They most certainly do. It's very hard to test them without a coil tester. So I want to show you a couple different types of coils. So here's the outside of the coil. There's actually windings or pieces of metal on the outside of this, so that this whole thing fits down inside the coil. Some coils were filled with PCB, so maybe it's not a good idea to take it any more apart. So this is an early coil, and it's very large in diameter because this is a sports coil, right? So a sports coil has fewer windings on the primary, which end up causing more electricity to come out, more voltage to come out of the high tension circuit. So this is a Lucas sports coil. Okay, it's got studs on the end of it, and maybe you'd have ring terminals on the end of that. So very few coils are labeled. They got all kinds of numbers on them, but they don't say how many ohms they have. Here's another a more modern coil, a Lucas coil, again with studs on it, for either taking ring terminals or putting spade terminals down underneath. Here's an aftermarket coil. This has got studs on the side, but it also has spade terminals. So what can happen here? This nut can come loose. The spade can come loose, right? And it wiggles just a little tiny bit. And maybe at 3,750 RPM, some magic number, there's an interference here getting electricity through there, and it fouls the action of the points and condenser, and you get a misfire. Maybe above that point you don't, maybe below that point you don't, but right in the range you can get a misfire, and that can be because the contacts here are loose, like loose tighten up the nut, right? Or sometimes it's the spade terminal pushed onto here. In a good tune-up, you take the spade terminal off, you squeeze it with a pair of pliers to crush it, make it tighter, and slip it back on again, just to make sure that connection is number one. Here's a Lucas coil, which has got spade terminals on it, but not with, I'm trying to show this here, but it hasn't got a stud down on the inside. It only has a rivet. It's just got a rivet down in there. And these ends this one's loose. I can feel it. I can jiggle it. It's loose. So what's going to happen? It's going to make and break a connection at some point. It's some vibration. So what you can do on this one is clean that up really well just down inside here. Take your soldering gun, clean it up, put some flux on it, flow some solder on it. Bingo, it's all taken care of. No problem anymore as far as a loose connection. So I continue to pull out these Lucas coils. This is a larger diameter coil that won't fit in a normal bracket. You see these brackets are slotted to fit anything. This one, the bracket is slotted, but it's not open. It's an original one. This is a coil that has been labeled junk, it says on the top, because over a period of time, if the coil is dirty, then the spark would rather follow the dirt and the water and ground out down to one of the low tension terminals rather than going through the spark plug wire. So it develops what's called a carbon track. So this is the top of this is plastic. Plastic's made out of oil. Oil's made out of carbon. So you burn it enough, and all you've got left is carbon. It makes a wonderful path for the electricity to take. You can see this so clearly if you're looking underneath the bonnet when it's dark outside. You're running the car. Maybe get a spritzer with some water in it and spritz some water on it. And if it looks like the 4th of July, it's either way too dirty or you're starting to have a problem with a coil having carbon tracks on it. This coil sold, another Lucas coil, but they put a gold on the outside of it, probably to get more money for it. But the guy couldn't get it out of the bracket, so he pounded it out. I don't know if you can see the underside here, but it's con concave, and it's anyway. He used a great big hammer. He says, "I couldn't figure out how to get it out of the bracket." It's like, oh my God, not with a hammer. As it turns out, this is internally shorted. So if you're running this coil and you happen to touch the outside of it, you get all that spark right into your finger. It really wakes you up. And I know that from experience. So over the course of time, different coils have come up, different types of coils. And Judson, who Coshocton, Pennsylvania, was making superchargers and go-fast parts for our cars in the 50s and 60s. This is the Judson electronic magneto. I mean, look at this. It looks like it'd go fast, right?
I guess I need one of those. No
Yep.
relationship whatsoever.
So anyway, so this is pretty cool. I don't know if it works or not. It's pretty cool. It's got some diodes on the side so that the points don't trigger all the electricity that's going through the coil. It's transistors. I mean diodes. The transistors are triggering what goes through there. But in the end, after all kinds of people have tried all kinds of ways, you know, just an old-fashioned coil is just fine. So again, there's two coils. One's a 3 ohm coil, and that's used 45 through 74 in 1980. 75 through 79, it's a 1.5 ohm coil because they reduced the voltage running the ignition circuit during the running cycle. So you're only powered by about 8 volts, 6 or 8 volts instead of all 12 volts. Talk about it later. So we've got the electricity going from the battery through the ignition switch into the coil, out of the coil, and into the distributor. So the distributor does 3 things, right? It makes the spark, it times the spark, and it distributes the spark. Right now, we're talking about making the spark. So down inside the distributor is a set of points. And when you turn the distributor, the points down here at the bottom open and close as it goes past the lobe. Oh, speaking of lobes, so you saw that's my best Moss Motors invoice ever, 11 May 1969. I asked him if the cams they were selling for the T-type distributors were symmetric, asymmetric, or high lift, and I got that note back, probably typed up by Donna Consoli, from what Al Moss probably told her, and that is, sorry, no information available on cams, but if you know enough to spell all 3, you know more than we do. Nobody type a letter like that today. Nobody type a letter today. But anyway, so here's the points, and the function of the points only is to disconnect the coil, and then when the points close again, to hook it to make it magnetize again. So this cam in here is turning at half engine speed. 4 lobes, so we're turning at half engine speed here. So those points bounce pretty fast. They open really fast, and they close. Um, they can close real fast too. And if you get going too fast, they won't close. They'll bounce when they close, just a natural thing. So during the 60s, there were special sets of points that you could buy for race cars that wore out quickly, but the tension on the cam lobe was a whole lot greater. So I'll put this back up here. This is again is the base plate and contact breaker plate, and the points are here. You can see the points open and close, and all that does is connect the coil to ground. That's all it does. Opens and closes. So it has to open a certain distance because there's a duty cycle. And as it turns out of 90 degrees, the points are open 30 and they're closed 60. That's the dwell. The dwell is the amount of time that the points are closed. So what can happen here? Oh, these wires get real crappy. You've got a ground wire here that runs to the distributor body. Sometimes that gets crappy. Sometimes the connections get bad. The low tension lead, that's real flexible wire. I don't know how many strands of wire there are in there. Right up here at the end, let's say there's 30, little like human hair size, and then 16 of them are broken. So obviously it can't handle the current that it should be able to handle. So there's all kinds of little things that can go on in there. This is the condenser. That's the condenser. That's the one that everybody complains about right now because it's so hard to find a good condenser. This one says uh, Brian Black, midget 1275, dead short, October 23, 2003. So this is just a dead short. If it's a dead short, the points don't open. Or this might be open and you don't get any condensing. So imagine that you've got a pipe, a pipe, and is a 2-inch pipe, and you got a great big valve on it that you can open and close real quickly. And it's open and the water's going through the pipe, and suddenly you close the valve. Well, what about the momentum? The momentum of all that water. I mean, it's in motion. And if you suddenly stop it, the pipe has to go in the opposite direction. That's why you get water hammer off your washing machine or water hammer. Some boiler systems have a problem with water hammer. So you put these devices in the anti-water hammer devices that are filled with air, and when the valve closes, the water rushes up into this closed container, compresses the air, then comes back out and sort of settles back down. That prevents water hammer. We're doing the same thing here, except with electricity. So when the points open, and the electricity would just as soon continue to ionize the air, and as the points are beginning to open and ionize the air, and you can't tell then when the coil collapses, it screws up the timing. You've got this condenser, and the condenser is no more than tinfoil and mylar. It's wound up in a little barrel, and it's just tinfoil and mylar, and it absorbs electricity. Not very much electricity, but some. So this is what goes bad. The condenser does not have to be on the inside of the distributor. It can be on the coil. It can be. As a matter of fact, later cars, 1977, 1977 through 1980, they were really after getting it right for the customer, and they didn't want little ticks. They didn't want that kind of stuff to get in the way of the AM radio. So they put a condenser, this condenser, on the power side of the coil. They also put one just like it on the voltage stabilizer up underneath the dash. They put it on the fuel pump in the trunk, and they put it inside the alternator, all designed to cut down on the zzz that you might get in your radio if you are listening to an AM radio. Otherwise, these things are of no consequence. This can be used on the other side. It can be used on the distributor side of the coil to do the condensing if you have to. So it's pretty straightforward. Let me show you a distributor here with the rotor in place, and you can see this is a 23D distributor, not a 25, not a 45, a 23, is it doesn't have a vacuum advance unit on it. This is used 1969 on sprites only in our range of stuff. Anyway, the points are on the inside. You can see the rotor come around on the here, and every time that the points open up, you get a spark. The spark comes into the top of the cap and leaves through a spark plug wire and goes off to the spark plug. But that's not the only way to switch the spark. You don't have to have mechanical points. In 1975, on the California cars, and by 76 on all the rest of the cars, they had electronic ignition, the Opus system, which was horrid. They all failed. But then they came out with the using a GM. That's what people tell me. I don't know. A General Motors design, and you can see the little. Let me get this here. See these little guys sticking out of the side of the rotor, the little metal pieces there. There's four of them. And as that goes by a pickup head, which is up here, like a tape recorder has a pickup head, as it comes by there, then it's electronically, with transistors and so forth, switched on and off. So these things are far superior to points in that once you set the timing, you never have to touch it again. It's just simple, easy. I'm going to hit the mute all. I got a little bit of background noise there, but anyway. So electronic ignition is great, but as we joke, it's pointless. If you have one electronic ignition in the car, you better have two. With these, with a set of points like these, you can always make these work, unless the condenser goes bad. But you can adjust the points with a screwdriver, a coin, a stick, tire iron. You can use a lot. I've used lots of stuff to get myself temporarily back on the road. But with an electronic ignition that fails, you are dead in the water. So if you have electronic ignition, you better be carrying a second setup, pickup and an amplifier. Now the Pertronics has all of it in a little tiny thing that's even smaller than this inside the distributor. It's a lot of work in a little tiny volume. This is just the electronic pickup part, and then the two-wire connector here. This is about 78 through 80. This goes to the electronic the controller with the transistors and so forth, which is mounted underneath the ignition coil, and that causes it to switch on and off. So it doesn't matter whether you use points or electronic. So some people are I'm real keen on points. So the two rebuilders, both Schlemmer and Medinsky, will tell you that they only want to work with points, not with electronic ignition. But if you're determined to have electronic ignition, then order two so that you can and carry that in your glove box along with a Phillips screwdriver, so that you can change the point plate in your distributor by the side of the road, or carry a whole nother distributor. And also the connections that go down to the coil. If you've got, let me look here. If you've got nuts and ring terminals, and you're standing next to I-95 or I-5 with a dead car, and you got the tools, you know what you're doing, it's still a whole lot. It's a whole lot nicer with those cars to have an ignition coil with spade terminals. This Lucas coil has a female spade on one side, or the female spade on this side, and the male spade on this side, so that it is identified as a low voltage coil for 75 through 79. Let's see. So once we make the spark, then the spark travels. Oh, let me grab this. The spark travels through a spark plug wire to the center of the cap, where there's this spring-loaded carbon brush, and then you've got a rotor on the inside of the distributor. There's a rotor that spins around on the inside of here and distributes the spark to the different spark plug wires in order 1, 3, 4, 2, and gets the spark out to the spark plug. So in the secondary circuit, if the rotor fails, you're dead. These don't fail and work erratically. You're off the road. You're just done. And keep in mind too that throughout the production of all the distributors, I have here this is a 23D distributor, which defines the body, the 23D. And from 1962 through 1974, on the bees and midgets and everything, this is a 25D distributor. Okay, it takes a certain cap, takes a certain rotor, and then starting in 1975, we have the 45D or DE for electronic, and that's got a different cap to it, different size. In 1980 only, get reach for all this stuff. So a 45D distributor takes a top entry cap like this, or it can take a side entry cap like this. And this has got a boot on it to keep the water out, but you know what it really does? It keeps the water in if it gets wet. Anyway, this fits all the way from 1956 with the MGAs all the way through 74. It's a long lasting style of distributor, and this will fit either the 23D or the 25D distributor. So why wouldn't you have a vacuum advance? That's the discussion about timing that'll come up. In 1980 only, why? They changed to a blue cap and a blue rotor. Why? It's a 45D distributor or DE distributor. I don't know why they're blue. Don't know. But if you're into originality and you got a 1980, you got to have a blue cap. So the stuff that can go wrong, your ignition switch can be faulty, although that usually evidences itself with the ignition light winking on and off. You can have bad ends on the wires where it goes into the ignition switch or into the coil. I think the MGA, the white wire from the ignition switch goes to the fuse box, and there's another wire from the fuse box down to the coil. It isn't one long wire. It almost always is. Then on the other side of the coil comes the distributor with the points, the condenser, and a real common error when you're hooking up the points, you decide you're going to do a weekend tune-up and you put all the stuff in it, car won't start, no spark, there is on this pedestal here, which includes the band from the points. It also includes the low tension lead, this guy, and it also includes the condenser. And these, if they're not stacked correctly underneath the points, it'll simply ground out or be open, one or the other. I've seen both of those. People call, my car won't start, I haven't got any spark. What'd you do to it last? Well, I put points in it. It's like, okay, don't be embarrassed. Lots of people have done that. So once the spark gets through the distributor and the points opening and closing, then the spark induced from the coil goes into the center of the cap, is distributed, hence distributor, to the spark plug wires, and there it is. So that's the primary and secondary circuits. The distributor does some other stuff too. You think of the size of the engine. How big's an engine? I mean, I can't lean back far enough. An engine's big, great big thing, right? Because you got three parts of this system. You got the engine, you got the ignition, and you got the fuel. So the carburetors, the engine's monstrous. The carburetors are a couple of fists big each, 2 or 3 fists big each, with the suction chambers and the float bowls and all that kind of stuff. But the distributor is only this big, and it does, yes, 59 MGI. Yes, yeah. So it's only this big, and it does three critical things. It makes the spark that we've just talked about, it times the spark, and it distributes the spark. So we've talked about distributing the spark. Well, we haven't talked about timing the spark yet. So down inside the distributor is just a minute here. I've got just a moment. Down inside the distributor, sure, you can see that. I don't think so. Do I get that light in there anymore? There's some weights down in there and some springs. You can see those. Kind of crappy picture here, but you can see the weights and springs. And I have one taken apart a little farther. So as this thing spins, as this guy spins, the weights on the outside move outwards, and as a result, the cam moves independently of the shaft. And the faster it goes, the farther anti-clockwise, the sooner the spark, this cam moves. And there's a number stamped on this finger right here. I don't know if you can see, probably not, but stamped on that finger there, it says 10. Okay, so that's 10 distributor degrees, which is 20 crankshaft degrees. So this is a cam out of a 40897 early MGB distributor. You want 32 degrees total advance. So if this is stamped at 10, but it's reading distributor degrees, you double it, you get 20. So your static setting should be 12, because 12 plus 20 equals 32. If you put a timing light on it, run it up to maximum RPM, where the weights have flung all the way out and the advance is all the way complete, then you should get 32 degrees. Of course, you can't have your vacuum advance hooked up at that time, because that'll bugger that up. So the weights in here change the position of the cam in relation to the points, advancing it. We also have a vacuum advance. Like on this distributor, here's a vacuum advance for drivability. And as you apply a vacuum on the end of here, whether it's from the carburetor or from the manifold, there are different vacuum advance units for both types. Then it changes the position of the points in relation to the cam, still making the timing come earlier than it would normally. And generally speaking, the total mechanical advance plus the total vacuum advance is somewhere up around 45 degrees. You don't get that except in unusual situations, and it's for drivability. Race cars don't have vacuum advances. Another thing to go wrong, you don't want these plates up on top that hold the points. You don't want these to vibrate. You want a solid plate. That's that 23D distributor that I keep pulling out here, wherever I put it. And this one doesn't have the vacuum advance. Therefore, the plate on the inside that holds the points is always firm, just like it is on a T-type. TCTD-TF. In 1955, when they brought out the MGA, they brought out a vacuum advance for drivability and a little bit of efficiency. Okay, doesn't have to be there, doesn't have to be hooked up, doesn't have to work. Your car will still run almost as well, but not get quite so good mileage. So let's look at 1975 through 1979. Instead of the electricity going directly from the key um, to the coil, it goes through a resistor. And it's not a resistor that you can look at and see. Well, you can see the wire, but it's about a 6 foot long, 8 foot long piece of iron wire that begins right underneath the fuse box and hooked up to some white wires, and then runs all the way to the upper left corner of the car. And there it's hooked to a white with green wire, which comes all parallels that wire, comes all the way back and runs the coil. The net effect is the resistance in that wire drops the running voltage of the coil down to about 6 to 8 volts. This is so that when you start the car in the morning in January with a low, with a choke that doesn't work well, and the car's turning over, going wrong, 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 that there's enough spark to ignite the gasoline. Cold gasoline does not like to burn, so it won't vaporize. And the function of the carburetors is to vaporize the gasoline, and it does that if the air is going through the carburetor. You're driving at 60 miles an hour. There's a lot of air going through that carburetor. It works really, really well. But when it's going wrong, 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 there isn't enough vaporization. There's not enough vacuum created to vaporize the gasoline, and the gasoline ends up going to the engine in great big drops. But if you get enough gas in there, it'll fire. That's why you have a choke. That's why it's really not a choke, a mixture control. And that adds a whole bunch of extra gasoline, just enough to get it going. Well, when you're cranking over at, say, your battery voltage nominally is about 13 volts, and you start to spin over a cold engine, the voltage in the system can easily drop to 11 volts, maybe even less. Okay, maybe 10 and a half. So the spark that you would get out of your coil would be less than normal. The government in 1975 wanted the cars to start briskly. They didn't want them cranking because that was spilling unburned hydrocarbons, raw gasoline, into the atmosphere. So they made the system work on a reduced voltage, but gave it full battery voltage at startup. So there's a pair of white with greens that power the coil 75 through 79. One comes from the starter motor and gives the coil full battery voltage, whatever that is at the time, but probably, 11 and a half, 12 volts or something, which is a whole lot more than the 6 that it normally runs on. So as soon as you start it up and relax the key, then the other circuit takes precedence and provides that 6 to 8 volts to the ignition coil and allows that spark to be normal again, not greater than normal. So once in a blue moon, one of those connections will break, 75 through 79, and you'll start the car, start right up, right up. As soon as you let the key fall back to on, kills. Starts right up, let the key come back to on, kills. It's something wrong with that circuit. And again, that resistor wire is sort of a shellacky pinkish wire that begins right underneath the fuse box and runs all the way up to the left front corner of the car, where it's married to a white with green that comes back to power the coil. In 1977, they thought, we're going to put an ignition relay into the circuit. This was to run the electric cooling fans. You've got a little tiny switch up on your column that holds the key. And heretofore, before 77, all the electricity that was going through the car, not the lights, but all the rest of the electricity going through the car virtually was going through that key switch. Well, that's a lot of energy to run through a little tiny key switch. And the cooling fans that they installed in 1977 draw more current than anything else in the car except the starter motor. So they're powerful, powerful fans. They're great fans. Replace them. Don't put one of those little tiny um, wispy little fans on instead. Buy the original fans. They are so good, but they draw so much current that it wouldn't go through the key switch. So they ran the ignition circuit through a relay. Well, that didn't work out very well because when the relay failed, then the car wouldn't run. And in 1977, they also had it wired in such a manner that if the anti-run-on circuit failed, that's the anti-run-on valve next to the charcoal canister. If that failed, then the car wouldn't turn off. You could turn the key off, pull the key out of the car. It's not dieseling, it's running. It's running. It's like, what is going on? Until the fuel pump would cycle. And then that we usually draw the voltage down too low and it would quit. So anyway, 1978, in about February 78th, they made a change on that. So 77 onlys, the ignition runs through the ignition relay. So unless you wire it hot, which makes a whole lot more sense. And then the ignition relay can go ahead and run the cooling fans and wiper motor and the washers and the turn signals and the brake lights and reverse lights, all that kind of stuff. And you don't have to worry about it running the car itself. Ignition circuits. You want all the wires to be nice and tight. You want everything to be nice and clean. You want just a minute, I gotta hit the mute all. And um, you want the points set correctly, which is on the T types, of course, the three different types of cams. So you got to look at the cam and go, which cam am I looking at here? Should the point gap be in 11 thousandths or should it be 15 thousandths with a high lift cam? So you got to decide which kind of cam you've got. Those are interesting. The symmetric cams look almost like they're round. The picture that I sent out in the picture in the constant contact yesterday shows it not as it appears. When you look at it, it looks almost round. And the high lift looks like a modern distributor cam. But the asymmetric cam, oh boy, that looks like somebody took a distributor cam and put it on a grinder in their garage or something or other. It's like, what's going on with this? So if it looks weird, the distributor cam, and that's on those early T types. But you never know what's fitted to a TF or to a TC, and all the distributors work back and forth. Anyway, got to get the right point gap, and that ends up being a certain dwell. I can't remember the dwell. It's 52 degrees, I think, for the early ones, and then it jumps up to 60, and it stays at 60, the dwell, all the way until the 41427 distributor used on the federal spec cars only in 1975, and then sold by all the parts suppliers as the Euro spec distributor. That's a 45D distributor that takes points. So that distributor was distinctly different, and that again had, going back to 1950 or 45, that has an asymmetric cam in it, and it has to do with how fast the points open. Okay, the cam comes around, pushes the points open, and then the backside of the cam is more tapered and allows the points to close more slowly, open and then close, open and then close. So that's an asymmetric cam on the 41427s. And that as a result, you end up with a dwell of around 52 degrees. It's still got a point gap of 15. Care and feeding, again, you keep it clean. If you've got an ohm meter, oh my gosh, so you can check your wires, you know, check your wires and make sure that the resistance is all about the same. A wire that's half again as long as the one next to it is going to have half again as much resistance because it's carbon filament wire with a resistance built into it. So the longer the wire, the more the resistance. The earlier cars had just straight wire. A note about dial back timing lights, and if you put those on the straight wires that you'd have like on a TD or something, the dial back timing light often won't work. And straight wires also kill protonics. If you've got resistor wires, it's fine. But if you've got straight wire, I lost 2 protonics in 2 weeks from straight wire. So I went back to points. I wasn't going to change the wires. Um, what else? So timing the car, we that comes under the tune-up and everything, but all of our cars, 1945 through 1980, not the twin cams, not the V8s, not the supercharged cars, all the rest of them. So 99.99% of all the cars have the vacuum advance, and you've got to disconnect that vacuum advance before you set the timing, but it's all set at 32 degrees before top dead center. Not 30, not 34. So again, I'll tell the little story that Carl Heidemann and I had a tuning for speed class in my shop in Ada so many years ago. We had a guy drive his MGB 67B all the way from Hershey, Pennsylvania. It was an 800-mile run. He came and we used his car as the guinea pig for tuning for speed. The first day of this tuning class was all about making it run as well as it possibly can in its present configuration. So before we pulled the distributor out, we checked the timing. It was 27 degrees before top dead center, full mechanical advance. So when we set it back up, when we tuned it, we put it to 32. We took it the next day to the dynamometer at Baker Engineering in Grand Haven, Michigan. Grand Haven's unfortunately just been in the news, a terrible murder-suicide. We put that car on the dynamometer, and we got 62 horsepower. Is that all? Yep. Hey, the rear wheels, that's what we're getting, 62. We moved the timing back to 27. We lost 5 horsepower. 5 horsepower on almost 10%. Okay, just from faulty timing. So timing is critical, and it's not. You can be artistic with your carburetors. Sometimes I encourage people that have got tiki cams that drive them nuts, tighten it up, because I don't understand how changing the clearance 4000s could make the car perform that much better. But let me tell you, getting the timing correct is critical, and it's always 32 degrees. You can get to that through a dial back timing light. On the late model MGBs, you can put a new timing mark on the front pulley, 12 degrees before the real one, and then put that 12 against the 20 on the timing marks on the cam, and 20 plus 12 is 32. You can get there like that. Or you can static time it. If you've got an electronic ignition, there are articles telling you how to do it. It's very difficult. It's not as clear as points. With points, you have a 12-volt test light, and you put it between the distributor and something hot. When the points are closed, the test light is on. When the points open, the test light goes out. You're not watching a meter trying to flick or something. So you put the distributor you get to roll the engine around in a clockwise direction and stop at the timing mark that you want. A T-type, which I showed in that constant contact deal yesterday, is top dead center because the distributor advances 16 degrees. 16 times 2 is 32, so you start at 0. So static timing on a T-type is 0. So you roll the engine around clockwise, until you hit the timing that you want. If you go past it, you can't just back up because that's the slack in the timing chain. You gotta back it up farther than that and come at it again and stop right where you want it to be, and then put your distributor in and set your distributor so the point's open at exactly that point. On an MGB with a 40897 distributor in it, it'd be 10 degrees. That's your static setting, because 10 plus 12, no, 12 degrees static, plus 10 degrees doubled is 32 degrees. So what else can I talk about? Spark plug wires, check them. Check them with an ohm meter. That's the only way to make sure. I haven't talked about spark plugs. I just saw a deal on, I don't know if it was on our website or someone else's, and a guy had two plugs that he'd taken out of a TF, and they were L plugs, half-inch reach. Just offhand, a T-type should have an N plug, a 3/4 inch reach. This is champion nomenclature. So you got to have the right spark plug. You've got to have a 35 thousandths gap in your plug. Workshop manual T-type says 20 to 22 maybe. MGB says 25. Open it up, make it 35. It takes a little more energy to jump that gap, but that means the spark is hotter. And my experience is that the spark plugs last just as long. I've never done um, a 300,000 mile test on spark plugs to see how long they last, but get them, set them at 35 thousandths. If you cannot clean your plugs, and by the only way to clean them is with a torch, and get them really hot so that all the oil and the carbon and everything changes into carbon dioxide and floats away, and you blow it out and it's all clean again. Or sandblast it. Make sure you get all the sand out of the inside of it. If you don't have either of those abilities, you cannot clean a spark plug. So you can just go out and buy new ones. New spark plugs are nothing's inexpensive anymore. I about dropped dead. I bought two sets of plugs at Napa a couple of weeks ago. It's like, what? It's like 45 bucks or something. I couldn't believe it. So you got to have the right kind of spark plug. Brand new spark plugs can be bad. Brand new wire kits can be bad. I was in Buffalo, New York in, make up a date, 1980, 81, something like that. And I was doing my rolling tech, even back then, working on cars out in the parking lot. And this guy had these spark plug wires that he paid $100 for. Oh my God, oh my gosh, they had weird ends on them and sheathing, and oh my gosh, they look, so I put those on his car. His car started to run ragged. It was only running on 3 cylinders. And they said, "What'd you do to my car?" I said, "I think one of your spark plug wires is bad." He goes, "They're brand new." It's bad. So you always check your new stuff. Points are almost always good out of the box. Condensers, it's very hard to tell. If a condenser is shorted, can't get any spark. Easy. Um, if the condenser is open or not connected or not working or it breaks down, then the car will backfire. And that's not out of the exhaust or out of the intake. That's not that. It's a rifle shot down the tailpipe. Donna Hathaway had her MGA on that on the rolling road in dyno at Baker Engineering, and she was running it right up. She was $6,000 or something or other, and the distributor popped loose. Popped loose. Of course, it's still turning a little bit and firing just erratically. I mean, as it slowed down. And Carl said, "Oh my God," he said, "I thought the engine blew up." I mean, it was so powerful. So a backfire is a textbook reason to suspect the condenser. So Medinsky and Schlemmer both say they've got excellent condensers, and they send them out with their products. They'll also sell them. The other ones that you buy through the normal channels. Glenn Lenhart from Glenn's MG Service said, they were making condensers perfectly fine for 100 years, And then like 10 years ago, they forgot how. Maybe it's where they sent the plant, but they're simple devices. Robert Dinsky says he winds his own. Is that really true? Anyway, oh, the rotors, the rotors.
Hey, John,
Yeah,
Roadster Factory has good ones in now too. He's been using the same supplier for many years.
okay.
He just posted it. I think, but they're up to $9 a piece.
Can't drive the car without it. No, okay, thanks. So these rotors, these rotors are plastic and have a certain dielectric strength to be able to handle so many volts. Right at the end of Lucas's original production, anything you buy today that says Lucas isn't Lucas, somebody's making it and buying the name, sticking the name on it. But back in the day, the last set they had, everyone suspects that the inside diameter was ever too small. And as you put it on and pushed the thing on with your thumb and got it on there, it would crack. And then the spark could jump through the crack from the brass at the top to the shank at the bottom. So I don't know if that was actually what was going on. Um, Then there were a bunch of bad ones by aftermarket people, and then out came the red rotors from Schlemmer, I think originally, and those are really good. When you're on a trip, maybe you should have a whole nother distributor with a cap and the wires, everything, so that if you diagnose your running problem as a distributor, maybe even you're struggling and you're just doing substitution, pull your distributor out and put the other distributor in. Its rotation is critical. But if the car doesn't run, I mean, look at where the old one was and put the new one in as close as you can, and it'll do just fine for until you can get a timing light back on it at some point in the future. I think that's about it. So I'm keen on getting questions about ignition systems.
John, this is Judd.
Yeah,
Uh, yeah, I've got a little picture up there that shows that wiper against the cam,
yeah.
and you
That's
look
a
at that
that's a
wiper.
symmetric cam.
Okay, thank you. That's one of my questions. Uh, the wiper is like a boot with a toe sticking out,
Yep.
and so if that toe breaks,
Oh,
you're on the side of the road.
yeah.
And it did. And I think the culprit was me, who didn't put grease on that cam. So you might just mention that putting grease on that cam thing, it used to be a little package of grease came with points sets. Don't know if it still does or not, but I'm fond of your big can of red grease that you always talk
Just
about. And just put a smear back there.
that
It's
just
important.
a smear of number two red grease. Oh my gosh, on the cam, just around it. You can get too much, sure, and get a great big gob in there. You don't want a great big gob, but you want some there and some on the leading edge of that wiper or whatever you want to call that thing on your cam. And you've got the little piece of felt in the top of yours so that when you put a drop of oil in there. The later ones don't have the felt; they just have the screw. I don't know if I can get the. I can't. My lighting is so bad you can't see down into whether there's a screw inside there. And since all distributors have a mechanical advance, um, and I've got too many hands here. You can't see what's going on, but um, this this cam turns independently of the shaft, and it has to have um, oil in here. So I had a customer who was going to go to the Peterborough, the first NAMGBR convention that we had in 1992 in Peterborough, Canada, northwest of Toronto. And she's up at high speed. This thing it would not run. It just wouldn't run right. And I asked him, I said, what did you do with the distributor? Nothing. I didn't do it. So anyway, come to find out, he'd used Loctite on the screw, which is down inside here to hold the whole package together. He'd use Loctite. That it had come out and jammed the cam against the shank, and so there was no mechanical advance. And you've got to have mechanical advance. The cars idle wonderfully at around 20, but they max out at 32. And you've got what that rate of advance is makes one distributor different from another. But yeah, you want to have grease on there for sure. The other one that I saw, I did a tune-up seminar at John Wright, who's Namgar #1, his son's brewery, no wine uh, winery in Solvang, California, in 2017. And we had a guy come in with a car that he had never had it serviced, never had it serviced. Well, this cam was rusted, rusted onto the shank. And I had that distributor out, and I mean, I'm in a winery. There aren't very many tools around. And I said, do you happen to have a propane torch? And he did. So we heated it, and finally we were able to lever the thing off, use some sandpaper, clean it up, put some oil on it, and yeah, then it ran great. So
One other thing before I let you go, John,
yeah.
that distributor that's in that picture does no longer exist. It's no longer in this universe.
Oh,
I was going at a pretty good clip coming out of Hendersonville when, the best I can tell, one or more of the springs that hold those weights into place gave up.
okay.
And the weights became a food processor down in there and literally destroyed the entire inside. Slimmer said, "There's nothing left here to fix." So that distributor is not even on the wall of shame.
Okay. Okay. Yep. I've seen people, you cannot service a distributor in the vehicle. You've got to pull the distributor out of the car, put it up in a vise, hold it in the vise so that you can adjust the points, so you can take it apart, so you can lubricate it, so you can do all the stuff to it. You can't do it in place. If you do, you'll take one of those cheesehead screws or the washer that's underneath it or something and drop it inside the distributor unknowingly, and then the weights pick it up and blow the distributor apart. I've seen that happen. So, yeah. All right. We've got Jerry Stewart. What's up?
Hi, good evening, John. Couple quick questions for you there. You see the
Yep.
distributor, it's
18
marked as an
degrees. Yep.
18. So you're telling me that's a 36. So how do I ever get to 32 advance on that?
By static timing it at 4 degrees after,
Ah, okay.
because 36 minus 4 equals 32.
Okay. Very
So this
good.
is how you got a 73, 74?
72. 72.
72. Okay. So the distributors, there's only one distributor that makes an MGB run the best, and that's a 40897, 62 through 67. But as it turns out, when you're trying to make the car emit correctly for emissions testings, the easiest way to control the emissions is fiddle with the timing. And so they did that almost every year from 68 through 80. Not every year, but almost. So here, you've got a vacuum. You're starting the car. You're starting the car extremely retarded, which is just fine. Just fine. And as soon as it gets going, it really advances. But you've got a vacuum advance unit, which is attached to your intake
Yep.
manifold. That if you check the timing at idle, with the vacuum connected, it'll be up around 30 degrees. It just loves to idle there, but you can't accelerate it from 30. So when you step on the throttle, all your manifold vacuum disappears. The vacuum advance unit then hasn't advanced it at all, and it falls back to the mechanical timing. So, and it's essential on that car to make it run well that the vacuum advance unit works. And those advance units go bad all the time. So put a tube on it,
Sugge-
suck on it, and see if you can get that spring to move. If it doesn't, get another advance unit, another.
Okay. Second question. I disconnected the coil, didn't pay attention to the polarity of it when I did it.
Okay,
And both the negative and the positive wires were the same color.
sure. Why not? Okay. All right. So all the coils are marked plus and minus.
Correct.
All right.
Yep.
So minus goes to the chassis. Minus always goes to the distributor. So minus always goes to the distributor, and plus always is the hot lead. So if it's positive earth, the hot lead comes down to plus, and the opposite, the minus, goes to the distributor. So in the earlier coils, they were marked CB and
Mhm.
SW. SW
Right.
was switch, that was the white wire, and CB are contact breakers, that was the white with black wire.
Yeah,
So
that's easy. That's the way the T-type is. That's the way my TC is.
sure,
But
sure.
this on the MGB, that was not as obvious then. So
And
it's a negative ground car.
in the end, it doesn't make any difference which way you hook it up. It just doesn't. But theoretically, it works better if the negative terminal is connected to the distributor, no matter what the polarity of the car is.
Okay, very good.
Okay,
Thank you so much.
you're welcome. Larry Smith,
Hey, John, how you doing?
pretty good.
Alrighty. I have a 1980 LE, and I have the 45, what is it, the DCI distributor.
Yeah,
The best I know that it works, it was running on the car when parked, one of those kind of things. And I have to admit, when I got the distributor out, everything looks nice and clean, and it looks like it should work. My problem is should I trust that, or should I just go ahead and get a points distributor and put in it?
no,
Because
you're okay.
I'm
Those,
redoing the car, my
those,
engine's out,
those,
and
that's a General Motors. Maybe somebody else knows a little bit better. It's a GM product, and it's really good, and they've lasted forever. They hardly ever go bad. This is the one with
I'm
the
just thinking
with
of
the.
breakdowns is what I'm thinking.
I just don't think you're going to have to worry about it. But if you wanted to carry another distributor, carry one with points and a wire, so you can attach it right to the negative side of the coil. Right? So you pull your distributor out, put the other distributor in, hook up the wires, and off you go.
And
So
time it to the best I can, and because I'm just looking to get home at that point. But well, I can do that then. Okay. Well, it's got me scared to death whether I ought to trust that. Should I just because
that ignition
like
system,
my
that system is really good.
okay,
Yeah,
good.
John.
The CEI system, I think.
Yeah, John, this is George.
Yeah.
Yeah, I love them. I love them. I switch all my B series engines over to those distributors, all of them.
Huh. Well,
But
that's good
but I
news.
probably should carry a spare, like you say.
If you carry a spare, you'll never need it.
That's right.
Well, and that's all I care about. Good. Thank you for all the information.
Hey, you're welcome.
Mhm.
Bob and Gloria. You gotta unmute. There we go.
Yeah, I've had electronic ignition. Well, late 80s, I bought a Crane 700D from a place called Fast Spec in Portland. And I used that up until I got a 123 from ignition from a friend. But the Crane, I put it in my 71 GT. I've never had a problem, but I'm not an idiot. I carry a points distributor because they don't give you any warning at all. I thought that the electronic ignition went bad one time. It was the stinking coil, black coil. I thought the distributor went bad, and Anyway,
Not the coil.
that
Rotor.
that rotor now lives somewhere in the woods outside of Glacier National Park. 'Cause I threw it as far as I could, and I just used the red ones. But with the 1, 2, 3 ignition, you can do a lot of things, and you can control it with your phone,
Yes.
and you can also disconnect it with your phone. So it'll start for a second. So now I have two anti-theft.
With
It's
a clutch. The clutch is the first one,
yeah,
right?
yeah, the clutch and
And the
the
1, 2, 3.
and the 1, 2, 3, and
Yeah.
but I love it. But still, even though I've never had a problem, I advise everyone, don't be afraid of electronic ignition, but carry that extra distributor
Oh,
with you.
yeah,
Hopefully, you'll
absolutely.
never need it. So, in fact, I had to make sure it's not rusted. It's in the back of my car.
Just another comment about a distributor. If you're on the side of the road and you're trying to pull your distributor out, the shank is aluminum and it fits into a steel housing, and there's a lot of oil everywhere. But there's also heater control valve right on top of it, and if that's ever leaked and come down the side, then it's corroded, and you can't get that distributor out for love nor money. We had a pair of channel locks. I mean, this giant pair of channel locks, great big jaws. And every now and then we get a car in, and the distributor was frozen. So you'd grab a hold of the distributor as tightly as you could. Of course, you're going to end up putting marks on it. You're going to put marks on the case, but you don't want it to slip. Once the channel locks begin to slip, then it scars it up even more. So you just get it and you keep shaking it, just a little shake it. All of a sudden you can feel it just move. Anyway, when you go to put it back in, bathe, bathe the shank and everything with red grease, number 2 grease. And then of course on a T-type distributor, there's a gear. So it'll go back in any which way. Oh my gosh, drive you crazy. You get it wrong. You just get it in your head wrong. But all the rest of the cars, the MGAs and so forth, we've got this offset dog at the bottom of the distributor, and one half is, you can see in my screen, the large half is on the right. So it only slips back into the engine one way. It's so nice. You don't have to screw around with the stuff. So I've got a story. The late Greg Purvis, I was building an engine at a tech seminar on Fulton Street 20 years ago. And of course, I'm encouraging everyone to have a nice, clean workspace. But now we're at noon on the second day, and I've got the engine together. I've got it upright, and it's just a mess of tools and rags and bits and pieces all over. I'm cleaning it all up. This is just after lunch, and I grab a rag and pull it, and out of the rag, rolled up in the rag, is the oil pump drive gear. I know I put that in that engine. I know I put that in the engine, but here it is. So I show it to everybody, and I said, "This is why you have a clean workbench." And then Purvis comes up to me and starts bumping my shoulder. "What's the matter, Twisty? What's the matter? What's the matter?" Okay, funny. Okay. He'd thrown an extra one out there. So a week later, we're doing a tune-up seminar, and he had the TNA guys tuning up a TD or something or other. And I hear him tell the guys, when you take the distributor out of the engine, look at where the rotor's pointed and put it back in exactly the same way. Well, that isn't the way I wanted him to teach the guys. I want him to roll around to top dead center, number 1 firing, so the 1 and 2 valves are loose, and put the distributor in so the rotor's pointed at 6 o'clock. That's where it's supposed to be. Judd's wasn't like that, but I didn't call him out on that. And so the number 1 wire leaves the cap at 6, and 1, 3, 4, 2 anti-clockwise from there, so that when the attack box gets loose, it comes over and can short out the distributor. Anyway, he told his guys, put it back where it's supposed to be. Well, I was miffed. So I went over and rolled the engine like 90 degrees or something or other. And he goes to put the distributor back in, puts it back in, tries to start it. It won't, of course it won't. It won't start for love nor money. And finally, he yells across the shop to us, "Yeah, I need your help. What should you do?" And I go over and I say, "Okay, this is the way you're supposed to do it. You know, top dead center, number one firing, rotor at 6 o'clock, put it in, time it with a test light. We're just doing put the cap on wires back on, start it up just like that." And Purvis says, "What did I do wrong?" And I said, "You put that oil pump drive gear in that rag a week ago. That's what you did wrong." So anyway, that's my distributor story. All right, we can
Hey,
talk a
John.
little bit more about distributors if anyone's got anything ignition
Uh,
systems. Otherwise, I'm going over to
John,
the chat section.
John,
Yes. Hey, Fred.
can you hear me?
Yeah.
All right. A quick question, or actually a quick comment. Distributor caps. I've gone through lots and lots of distributor caps. Everybody does a tune-up when they replace the distributor cap, right? So I started measuring the center lead from the conductor to the brush, and I found that a whole bunch of my distributor caps were reading like open or 20,000 ohms or something like that. So what I found is Moss actually sells a distributor cap brush. They only
No
listed
kidding.
under the TR3, but you can pull that brush out with the spring, put a new brush in there, and restore the cap to new condition without having to buy a new one.
So what we're talking about is this brush right here in the middle that is
Yeah.
I can't, spring loaded. And if when you wash the cap off, when you're washing everything all off, soap and water's fine, carb cleaner's fine. You get your air gun and you're spraying down in here, and psh, that that center electrode goes across the shop, never to be found again, because it's just this. It's just this. So we're talking about the length of that and the spring that goes with it. And okay, thank you.
Hey,
I'll
John.
run without those.
I can't.
Not very well. Oh, and I did want to mention that I didn't have a 6 cylinder and a 4 cylinder rotor someplace. Anyway, this is a 4 cylinder rotor here, but a 6 cylinder rotor is longer. It's longer. And you can put a 4 cylinder rotor on a 6 cylinder distributor cap or distributor, but the spark has to jump so far that it screws up the timing. It looks like the timing is right, but it under load it does not work correctly. And I've solved a couple MGC overheating problems because of an MGB rotor on the inside. That said, I got a midget 1500 in the shop one time, bad compression on one of the cylinders. Called up the owner, said it must, it's got a bad valve. What else would it be? It was a hole down the side of the piston. So anyway, had to have the head off anyway, and put another piston in it, and got it all together. And I'm trying to time it with a timing light, and I cannot make it run unless it's running like it's 60 before or 30 after. I mean, it's just crazy. I cannot get this thing to run right. And I look at it, and of all the different ignition systems that there was one called Luminition, which uses a wheel with slots, and it's got an electric eye. And as the wheel turns, as the I can't as the wheel turns, the eye either can see or can't see, and it switches the coil on and off. Anyway, the problem with this Midget 1500 was they had a 6 cylinder wheel in a 4 cylinder engine. So two of the sparks were coming real early and two of the sparks were coming real late. And as a result, it burned a hole in the side of the piston. There's no end to the weird stories, of course, you can come up with. So anyway,
Hey, John, before you leave the subject, one more question. You touched on it just then. Talk to us about the relationship between timing and overheating.
so if it's retarded, think of that gallon of gasoline that you buy that's got 120,000 BTUs in it. And when everything's running perfectly, um, uh, one third of that, 40,000 BTUs, is available at the flywheel, right? The other energy either goes out in the radiator or goes out the exhaust. So by changing the timing a lot, getting it wrong, if it's retarded, the car will get really hot. And if it's over advanced, it can also get hot, but it won't evidence itself on the temp gauge. It just gets way too hot inside the cylinder, and it'll also knock, ping, pink. There's a whole lot of different words for that, but it's that diddle that you get when you go to accelerate, and it sounds like there's a bolt loose inside the engine. It sounds metallic. And so that's really dangerous for the because there's so much more heat and pressure involved with the valves and the pistons. So getting the timing right is just magic.
John, I got one other question I need to ask you.
Okay.
Yes. And a real quick story. The real quick story is on the points, the pivot point stud. I had a set of points that when the car heated up, they'd stick open, and it was just too tight on the pivot point.
Yeah.
Ran into that, drove me crazy.
Yep.
Okay, the question is on your rotor. You'll see rotors that just has a little stub on them, then some that has a finger. What's the story there, and what do you think about it?
You know, it has to do with phasing. So when this guy comes around, and the spark comes, and you want the spark to occur here at 1 o'clock. So if the spark comes here and the rotor's between the two pickup points, you can lose your spark altogether. We've had trouble with Pertronics that are phased wrong, but this guy should be right against the cap. But of course, it moves. It moves, having to do with I keep looking for I got all my stuff piled up in this massive pile next to me on my kitchen table here. Anyway, some of them have a pretty long finger, and that's to assure yourself that you don't have a problem with phasing. So I would go for the longer finger. I would, you know. And then there are other rotors that have a mechanical device in them that under high speed begins to move out away from the rotor, and it grounds out the spark. So you cannot over rev your engine. And some of those are adjustable. So that's all back in the day stuff.
Would that be called a governor?
Yeah, yeah, absolutely. Yep. So I'm just going to take a look underneath here. Oh, this is yet a different, there's a whole bunch of different rotors. This is a 25, like a 25D rotor, but look at the counterweight on that. That's a huge, I mean, if you get a rotor like this that's spinning around, it's constantly causing the shaft, to want to wallow around. But this thing looks pretty balanced. This is a nice one. So let me snap this thing back together here. All right. And I have John Borg up here who's patiently waiting.
Hey, John. Can
Howdy.
you hear me?
Yes.
Oh, cool. So I had a question. You had mentioned that there's this 1.5 ohm resistor coil and there's the 3 ohm resistor coil.
Yes.
Did I hear you right? Yeah. And so if I'm switching I have a 66 MGB, it's got a 45, that's all it says on it. It's a 45D distributor. And
Okay.
I bought a distributor from Jeff that's a 25D and it's the 4897.
Mm-hmm.
And Would I need to switch that coil somehow?
No, no, the coil has to do with the voltage in the car. So it doesn't
Okay.
matter. The point, the distributor is just a switch. So you're being powered with 12 volts.
Uh,
That 12 volts should run into a 3 ohm coil.
okay. And I can test that just with an ohm meter, right?
You can
Just
test
to make
that with an
sure.
ohm meter. Yep.
Yeah. Okay, because there is some dodgy looking wiring down there, and I was a little nervous that somehow maybe somebody rewired that section.
Could be, you've got a wire that comes from your key switch through the impulse loop in your tachometer and then down to the positive side of the coil. So it's a single white wire that comes from the key switch through the impulse loop and then down to the um, ignition coil, and then another wire from the ignition coil to the distributor.
Yeah, okay. I do have a follow-on question,
Sure.
and that has to do with when I was looking at the workshop manual, which I could bring a picture of it up, but um, it says like for my car, for my engine, for the 44089.7 distributor, and it lists this crankshaft degrees, 6 degrees at 600, 6 degrees at 700, 9 at 900, 15 at 1600, and 30 at 30 at 20 200 RPMs. So I'm kind of new at this, and I hear you say 32. So how do I don't understand the difference between those two. It
So
said,
static time it. Don't use a timing light. It's a brand new distributor.
uh,
If it's the 40897, it's got a 10-degree cam. So roll the engine over until you're 12 degrees before top dead center. Of course, you're underneath there with a wrench, 1 5/16 wrench, pulling on the engine. Or worse, you're underneath there pulling the whole engine, pulling the whole car, or having somebody push you. They always push you too far. You always go
mm.
beyond the timing mark and back up and come at it
And I
again.
would I would know that number because of the ticks, the extra teeth that are
So you got a 67,
66,
66, you got 3 or 4 teeth there, right?
right?
At the bottom. So the last tooth you come to, the one at 6 o'clock, the last one you come to in a clockwise direction is 0. Each
Uh,
mark before that is 5.
I see.
So, and if you got only 3 marks, then you got a 10-degree mark. So estimate 12. If you got 4 marks, then you go between 15 and 10. And again, estimating 12. And then use a 12-volt test light. I'm sure in the workshop manual it tells you how to static time it. So,
Hmm.
but roll it around to 12 degrees before top dead center. Then put the distributor with a lot of grease into the block and get the clamp sort of snug. But you can still turn it. And then hold the rotor cap off, hold the rotor clockwise so the advance is all the way off. Turn the distributor clockwise until the light just goes out.
Mm,
Hold the rotor clockwise, turn the distributor clockwise until it just goes out, lock it down there. And that's your timing is going to be all but perfect.
I see. Okay, so then don't do the timing running after
Well,
that.
it's I mean, maybe Jeff's got it set so that it is correct, but the bottom line is it's you only know for sure that it's correct at the bottom or the top. You either got to have a dial back timing light and do it at 32, vacuum disconnected, or you
Yeah.
can do it static at 12.
Okay. Yeah, he did write on there, on the little bag, it's got a number, and I
Yeah.
assume that number is for dynamic testing. So yeah. All right, I appreciate it. Thank you
Yeah,
very
you're
much.
very welcome. All right, we're going to move over into the chat section tonight.
One quick
Oh, yeah,
question or
hey,
one quick comment.
absolutely.
When you're pulling that distributor out and putting it back in, especially the 45, I mean the 25 Ds, make sure your bales are up. You put a rubber band around them or something when you're sticking it in, because if your bale is down, you can't get it past the starter motor.
Yeah, and then you got to take it back. So we're talking about the clips that
Yeah.
hold the. It's so frustrating to have it down underneath there, and then you go,
Oh,
oh my God, I got to do this again. Yep. Yep.
yeah, I
Thank you.
mean, this distributor, when I took out the original distributor or the distributor that's in there, I took it out for another reason, and I did what I just put it back in where it was.
Yeah.
But I do think that that gear, that drive gear underneath, it's pointing to like 4 o'clock
Well,
when I took it to TDC.
okay.
So
So when the engine is at top dead center, number one firing, the rotor should be at 1 or 2 o'clock. It doesn't make any difference where it is as long as the spark plug wires go to the right spark plugs. Okay. It can be at 4 o'clock, it can be 6 o'clock, it can be at 10 o'clock. But conventionally, you put it in at 2 o'clock, and that's predicated by the position of the distributor drive gear. And to get that out, to change that, you need a long bolt, the bolt that holds your air cleaners in, and you can thread that down the middle of the gear. Gotta know what you're doing because you don't want to drop it inside the engine, do you? Or just let it go the way that it doesn't make, as long as the wires are going to the right spot, it doesn't matter where it is. Someday when when you get braver, and you go, that really bugs me. I'm gonna get that rotor up there where it's supposed to be.
but that 25D will go on there where it is now, right?
Yes.
That's
Oh,
really the why.
absolutely.
Yeah, okay.
Absolutely.
So I'm not going to worry about it. I'm just going to leave it
Yeah.
there.
All right.
Just
Yeah. Okay.
John, can I ask you a question about setting points?
Yeah.
So what's your technique? I use feeler gauges.
Okay.
This is Rob Tedrow.
Yep.
And I convince myself that as I'm trying to tighten that point setting up, I can push out and watch one set of the contacts move away from the other.
Okay.
And then I get nervous that I've made it too big or I've screwed it up. So if I'm at the side of the road and I got a hot engine and I don't want to get my fingers too close to the heat, what is the best technique to get that point gap setting correct? Because I've had mine close up on me due to some stupid mistake, and it screws up my timing, and then the engine doesn't run well until I get the gap right, and then everything falls back in place.
I think for every degree of dwell, you lose a degree of timing. I don't think it's 2 to 1. I think it's just 1 to 1. But it's pretty intense. So I'm looking for my plate here. First of all, the plate that holds the points, you want to have underneath that cheesehead screw, underneath the cheesehead screw that's right, you can't see. Where is that? Right here. Right here. Underneath that screw, you want to have a number 10 lock washer and a number 8 flat washer, so that the flat washer is against the points and the points don't move when you tighten up the screw. Okay, number 1.
Okay.
Number 2, put the distributor in the vise. Hold it in the vise and spin the bottom. Okay. And you put a feeler gauge, a little tiny thin feeler gauge between the points up above, and adjust them so that when you turn the bottom dog, you can just feel it brush the cam rider. Okay. So put it in there at 15, sitting at 15, and then move the points in and out wherever they have to be, so that as you turn this and it comes around to catch the cam, that it's already open 15, so it just barely brushes the top lobe of the cam. And by doing that, you can feel how much it's brushing on each of those 4 lobes. And if 2 lobes, it's opening the points, and on 2 lobes, nothing's happening, you know that the shaft is bent, and now your firing angle, which is supposed to be 0, 90, 180, 270, is all buggered up, and you got to send it off and have it repaired. So anyway, but I put a little thin feeler gauge right between the points and then reach underneath and spin it until I can feel the cam just brush against the cam rider with a 15 thousandths feeler in there. Lock it down there.
And that's the best way to do that. If you have it back at the house and you decide you want to check the point gap, is to pull the distributor and do that versus trying it
Yeah,
in the
well,
engine.
if you're gonna move the points, you're gonna change the timing. So
Okay.
yeah, it's like whoa. So that's why you only do it once in a while.
Yeah. Yeah. Once it's dialed in, it seems to work great.
Yeah.
Okay.
Okie doke.
John, I have a quick question. This is Milt Babarak.
Hey, Milton.
And by the way, I'm enjoying the session. It's really great. Thank you.
Thanks.
It's been a long time. Could you show us on the body of a distributor where you find the markings to know which kind of distributor you have?
So this one says, see this flat area here,
I see, yeah.
right? So this one says this is a 41491, and the build date on it is 3372, the 33rd week of 1972. So Fred, when are you going to start doing this on distributors too? You've already done the carburetors. You got to start doing the distributors. So this is a 41491A. Now a 41491 has a different advance curve and a different vacuum advance than the year before or the year following. Again, it's all for emissions. So it's right, it's stamped on there. You can take it out of the car. Your distributor isn't a 25D, yours is a DKY4A probably, but it's still got a number on it. A TC is a 40048, and the most common TD is a 40152. But I don't, you got a 53, right? You're muted, Milt. You're muted.
I'm sorry, thank you. I've got a 51
Oh, that'll be
and
a 40152, yeah.
40152.
But it can have any one of those three cams in it.
Yeah. Actually, you one time looked at it and said, "Well, I'm not really sure." And they're so close. They're apparently hard to tell apart. And
You
and I
snap the cap off, take a picture of it, and text it to me, and I'll make another armchair determination.
all right, excellent. Thank you, John.
You're welcome. So Bill Thornton, you've been waiting a bit. Bill, you got to unmute yourself. You got your hand up. Here we go.
Yeah, I know I was messing with my mouse,
Okay.
it wouldn't click it off. But I've got a 79 MGB, and according to the MOS catalog, can you hear me? Okay.
Yes, just fine.
Yeah. Okay. Yeah. According to the MOS catalog, my car should have what they call an Opus style electronic distributor.
Yes.
Fitted from the factory. What's an Opus style in comparison?
It's the most horrible one that they ever had. They all failed.
Oh, go figure. Yeah.
Well, they put all the transistorized switching equipment right into a block on the side of the distributor. And
Okay.
I back in the day in 75 when they all started failing, I said, you can only take, the electronic watches, the Cadillac of electronic watches at the time was an Accutron watch. I said, you can only shake it so much and put it in the oven so much it's going to quit. And that's what happened to these things. I can't tell you the last time I even saw one that was on the road.
But on the same sort of page in the MOS catalog, it says that the CEI electronic distributor 1980 is a direct replacement for the 75 to 79 Opus. So my question is, if I'm going to buy a spare to carry around, it would be the CEI model.
Oh, but that takes an external module. So if you were going to buy a distributor to carry around, you would buy just a contact one of those two distributor guys, or just buy if just to carry to get around, just buy one of the ones that's online, and provide a piece of wire so you can get from the
Yeah.
distributor to the negative side of the coil.
Yeah. Okay. All right. I just wanted to ask, and
Sure.
I have one more question if we have
Yeah,
time.
go ahead.
You were talking in depth about 32 degrees B to
Yes.
DC. How do you measure it?
But
Where do you measure it?
you use a dial back timing light.
Yeah.
Now on your car, you have 5 marks on the crankshaft cover. So the last mark you come to is 0. Each mark before that is 5. So you got a total of 20. So what you could do is roll your engine over until it's at top dead center. The notch
Yeah.
in the pulley is opposite the 0 mark, and then take a paint pencil, make a new mark on your pulley at 12 degrees before
Okay.
top dead center.
Yeah.
Now, when you time it with a regular old-fashioned timing light, not an advanced timing light or dial back, just a regular timing light, vacuum disconnected, you would see when it's timed correctly that the new mark that you made with the whiteout or the paint pencil is opposite the 20 mark because 20 plus 12 is 32.
32. Got it. Thank you very much.
What's a
That
dial
clears it
back
up.
timing light?
Thanks, John.
The,
I'm sorry
the,
someone interrupted, but
No,
I'm
that's
going to shut
okay.
up
It's
now.
the dial back timing light is the timing light at Napa or Canadian Tire that the 19-year-old clerk pulls off the shelf, dusts it off, and says, "I've never sold one of these before." So it waits after the last spark, and so that it it flashes the light before the ignition fires. Well, it can't tell the future, so it's timing it off the last spark. But um, it effectively, you get a little dial or a push button or something rather, and you can go to 2 degrees before top dead center or 60 degrees before top dead center. Set it anywhere, but you'd set it at 32, and then when you're looking at it, the apparent view would be when you're looking at the timing is that the 0 mark on the front cover would be opposite of the notch in the pulley. And so that the 32 was taken up by the dial on the gauge on the timing light itself. I don't know if that was a good enough explanation or not. So anyway,
Good.
Jim Holiday, haven't talked to you for a long
John,
time.
I know. Good to see you.
Yeah,
We're always diagnosing misfires at the track, right? And
sure.
and so my question is that I always took the opinion that either a coil is good or a coil is bad. It's not, there's nothing in between, but that's not the
No,
case. Huh?
no, 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 no.
Besides the loose wire thing. So
Yeah,
a
no,
bad
no. There's
you can have
you can have coils that break down. I just worked on a guy's TC last week, and you know it revved up. Oh my gosh, ram, great. Everything. You go out and start doing about 20 miles an hour with your foot into it, and it just snapping and popping and everything. And so we took some pink duct tape, took a pink duct tape in this nice TC, duct taped a coil onto the fuel pump. I know that sounds safe, and ran the wires to it, and it ran perfectly. So it was just
okay,
it was a bad
okay.
a bad coil. And almost all the original T-type coils are bad. They've just timed out. Now you can buy new ones that look like the original ones, and I don't know if they all work all the time or not. Probably not. But
Can you test a bad condenser? Is there a way to test it?
it's really, really tough. It's almost always by substitution. If you've got
Okay.
a moving coil ohm meter, and you hook up the two leads to the connector and the ground, you hook it like that. The needle on the ohm meter will just flick, and then you reverse it and put it the other way, and it flicks about twice as far. So
Okay.
that doesn't tell you that it's good, but it might be. It's the inside of this. When I had it apart and showing you all the tin foil. I don't know where I put that. It'll break down. There's a when the field collapses in the coil. Not only do you get the 1800 volt surge out of the secondary part of the coil, but you also get 100 and some volts out of the primary side of the coil. And that's what the condenser is protecting the points is at 100 volts. And sometimes it'll jump through that mylar. It'll jump through the mylar and the coil will break down. That'll break down. So you can run a condenser right on the distributor side of the coil. Just put the condenser there, and then you don't have to go inside and keep chasing all the time inside the distributor. If the track guys won't let you, I mean it's still a condenser.
Last question was you can use an ohmmeter to check spark plugs, right? To see if the spark plug is got a leak in it or not.
Well, yeah, sure. I suppose you should be between the electrode on top and the threads, you should read zero.
Yeah.
But
Okay.
if it's carboned up, sure, you'll get 100,000 ohms or 50,000 ohms or if it's been crunched, 0 ohms, sure.
I love the setback timing lights, but at the track, no two setback timing lights work the same. Like they're all different.
Yeah, it's old technology and that hasn't kept up. And I think I bought 3 new timing lights in the past 10 years. They quit working. I don't know. Static
Good seeing
timing's
you.
nice,
Good seeing
but
you again.
hey, Jim, it's a pleasure. Say hi to
Hey,
Sid.
John,
Yes, sir.
this Mike down in
Yeah,
Pensacola, Mobile.
yeah.
I was just going to say the more expensive multimeters that you can get nowadays actually has a microfarad reading. And supposedly these things are supposed to be around 22 microfarads.
Yes. Okay. Okay. It still won't tell you if it breaks down under
No,
load,
it's not going to say if it's breaking
but
down.
it'll tell you if it's got the right capacitance and yeah.
Most of the time, if it's breaking down, it's not going to have the right capacitance.
True. True. Okay. Thank you. All right, Jim, you still got your hand up?
No, sorry.
All right, that's okay. All right, so now it's 9, and we've talked about this stuff all the time, and I haven't got to any of the chat. So I'm gonna run. I'll run until 9:30, and then that's it for today. But let me try to catch what I can here, and sometimes it's hard to read all the stuff on the chat. So let's see. Um, Judd says, um, I did too. The big red link wanted me to download some kind of app. I don't need any more apps. I copied the small font gray URL and pasted that into a new tab. Oh, we're talking about getting on tonight. That's it. So who
It
has
was a bit of a kink because we've
Oh.
always just clicked on the nice big red link, but this time it wanted us to
Uh-oh.
download some Zoom workstation crap.
Oh, that's
And I
what
don't
this
download crap.
Eska Zoom's probably upgraded or something or other. Yeah.
Yeah,
So,
Yeah,
check
so
your,
we'll just have to switch out the links.
yeah, Zoom does, right? Yeah. So
Yeah.
Bob Whitfield wants to know who's got the oldest TD. That would be TD0251. Where is TD0251? But maybe he meant on tonight. Blair Weiss says he's got 908 solid wheels. Although they shouldn't have solid wheels by then, they discovered that they had to ventilate the wheels to get the brakes to work right. So it's Blair's with the New England MGT register, and if you have a T-type, they need you, you need them. Join, and maybe they'll tell you who's got the oldest one there. Is
You usually ask the question, who's got the oldest MG?
Yep.
And I was just curious who might be on that has the oldest TD. I know that mine came out in January, came off the assembly line, January of 1950.
Okay. Is that the one that's in the yellow there with the drilled wheels?
Yes, sir.
Okay, because it should have solid wheels if it's that old, but that's okay. And they got grilling shocks. So what's your VIN?
I think it's 591.
Oh, well, that's earlier than Blair's then. He was 908. So very cool. Very cool. Let's see. David Basili says, has anyone installed a voltage gauge or an amp gauge in the radio slot on an MGB? Voltage gauge, if that makes you happy, do it. Ammeter, do not, do not, do not, do not. Can I say that any more emphatically? Do not install an ammeter. It's a heavy wire that carries all the current that runs the car, and it's extra wires. It's through holes you punched. It's just a problem waiting to short, and you can let scores of amps through a 14 gauge wire. Not for long, it turns red hot and catches other stuff on fire. Voltmeter, if that makes you happy. But you should expect 14 volts. When the car's running all the time, you should expect 14 volts. So let's see here. We got, oh yeah, right. I just put a voltage gauge into the cigarette lighter. Yep, that's what John Bendicia said. So, and I was able to replace the cigarette lighter socket with USB that also showed the voltage. So that's cool stuff. Dave Smittle. Hi, John. I'm having trouble with the distributor on Docsmith's 53YB. It's a DA36, the DKYH4A, I believe made in October 49. I have had friends helping me with no success, so I was going to put a Protronics in it just to get to Sandusky. If you have to, go ahead. And by the way, do people know they can take their car there ahead of time? There's free storage offered in one of the large indoor boat storage facilities. Contact Tom Metcalf. So if they didn't know on this call, anyway, that they can take their car in a little early. The DKY 4A, 4HA. I don't know. I don't know what the scoop is on that.
That's the purpose of my question.
Yeah. So take
What's
a
a DKY H4A?
I don't think so. Why don't sometimes it just has to do with which series that they were making that stuff. Take a picture of the top of the distributor and text it to me. And just I would think that when they were setting that up at Pertronics, I remember I talked to a guy named Scheer, Scherer. He was the engineer doing it, and they had to get a something that would slip over all three of those cams, the symmetric, the asymmetric, and the high lift. And I had all the specs on those cams. So, and you can't get points to work, Dave?
No. I had a buddy even coming and helping me, and we're not getting any sparking at the points. We're not getting any sparking anywhere. But we put a new coil on it.
Call me tomorrow or something, and let's see if we can sort it out. So
okay, thanks.
So
I was just wondering what the DKY H4A, and then it says 40089B.
40089. That's the distributor number. 40089 because the TC is a 40048. And a TD is a 40152. So it's just, just that distributor, but I don't know. I can talk.
So when I'm doing the Pertronics distributor lookup, instead of doing the DKY, do the 40089.
I don't think you'll find it like that because they are assigned to bodies. Your body's a DKY4A, I think.
I just wanted to get this car ready and up there.
Yep, I understand. Yeah, talk to me about that because it with the points it ought to run. It's just an old engine. It ran
New,
fine when it was up
new,
here. That was a
new
long
point,
time ago.
new points, new coil. Yeah, yeah.
Something's hooked up wrong. Something shorted out. Send me a couple pictures of it, and I'll see what I can do.
Thanks, John.
Thanks. So Neil Thomas wants to know if the session recordings are available later. Yes, on YouTube. Don't know how long it'll take to get this one up, but it'll be. Oh, Marty says, yeah, they go on YouTube's, but they go on YouTube, but sometimes not for a while. That's today's understatement. Brad Schwartz, a friend of mine has a recurring problem with his MGB clutch hydraulics. After driving the car 50 miles on a hot day, it becomes difficult to shift into first and reverse at a standstill. Other gears are harder too, but easier because the car is moving, he thinks. If the car sits for a while, the problem goes away. The problem never happens in winter. I don't know what it is. I've got a guy who's has this problem with a midget, and he drives it for 50 miles and hits the pedal, nothing. And then he pumps it and it starts working again. Brett, I don't know what the problem is. I just don't know.
John, is that a fluid driven slave?
Yes, absolutely.
What about
It's probably
how
a flex.
the
It's probably a
inside
flex
of the
line
rubber can
fatiguing.
swell with in
Sure. Yeah, but this is in the case of the midget, everything was new. Everything was
He
the
gives the
master, the
same.
slave, the hose, everything was new. And it's like, so what is it heat? Is there a problem with the heat? Is it silicone fluid? That gives you weird
Oh,
problems.
it's
Hey,
regular
John.
fluid. He was wondering if there's water in the fluid and if the fluid needs to be changed. If there's something
Yeah, this in
vaporizing in
what?
there.
Well, sure. I mean, you do everything you possibly can, but I don't. I've seen this. I've seen this. I don't know what the problem is.
John, I had an issue similar to this 4 years ago,
Yeah.
and we took the gearbox out in a 1980 MG, and the interlock arm was the only thing in the gearbox that appeared to have damage. It had a hairline crack. I talked with you about it. We hammered back and forth, couldn't figure it out. I ended up at Car Sportsman in Arvada.
Right.
And since they don't make the interlock arms anymore, I got a used one from him and put it in, and miraculously everything was fine.
Yeah.
And I responded back to Bradley with that information.
Okay.
Not sure if it would help at all.
Yeah, it's this is a hydraulic pressure loss. So it's a real weird thing. I'm interested. Yeah, I'm interested to get that one sorted out. I only know two cases of it now. This is the second.
Okay, well, if he solves it or when he solves it, I'll tell you.
Okay, all right. So, Mr. Dowler, I replaced the ignition spark plug leads with new set, but made the mistake of getting the leads mixed up where they connect to the distributor cap. I referred to an online diagram, and the engine would not start, no fire. And finally was able to determine that if I took the proper head distributor arrangement and rotated 180 degrees on the cap, then the engine runs very well. Okay, so when you take this apart, when you take this guy apart, and there's a screw down inside here. Oh, there's a screw down inside here. And you can take this whole thing apart to clean it. You can put the cam on backwards, 180 out. That's easy. Or you can put the distributor drive gear in the engine, 180 out. That's a possibility. So it's just there's a way that's conventional, but it just doesn't make as long as it's running, you can set the timing. So David Halliday says he's had two Protronix igniter fail on a ZBV magnet. They happened a few years apart. Don't know why. I've had Protronix igniter on my factory V8 for 18 years, thousands of miles without a problem. So I don't know why the magnet might be causing it to kill, unless they're newer units. I think the older Protronix were better than the newer Protronix. I think that's my gut. I have no data to back me up on that. But they great. Their failure rate was minuscule. Now the failure rate's higher. So
John, you mentioned something about the non-carbon, the copper spark plug leads can damage. I wonder if maybe on the older ZB versus his modern V8, he might have non-carbon wires, and you said maybe that could break a Protronix. I don't know.
Sure, could be, could be. So Dean Hickenlooper asked what what the distributor gap is on a dual point Mallory, and I don't know. 24,000 seems that's really big. That's really big. I'm not sure, Dean, what that is. I do have information on it, but I'd have to look it up. I don't know off the top of my head. So the reason you got a dual point distributor is to increase the dwell, to give the coil more recovery time. So you got two sets of points wired in parallel. So as soon as one set of points closes, then you're charging up the coil. Second one closes, you're still charging the coil. First one opens, you're still charging the coil. Second one opens, you get your spark. And so with points working at different placements around on the inside of the distributor, you can increase the dwell dramatically. David Cray, I've got an 80 LE and the distributor has a large black box as part of it. And what type of distributor this isn't correct for 1980. So that is probably the CEI. It's about twice the amplifier is about twice the size of a pack of cigarettes and is bolted on underneath the ignition coil. So Mike Cunningham. I have two distributor stories I'd love to share if you get to me. Here I am. So, Mike, did you hang on all this time to see if I'd get to you?
I'm here.
Okay.
So the first story is back in 2001. I have an MG 75 midget, and I had that Opus distributor,
Right.
and it would just randomly quit usually when the car was nice and hot, and I would start pushing the car or whatever, and then I'd try again and it would work. And back then didn't have YouTube, so I had to figure out on my own that it was the distributor, so I replaced it with a Crane distributor. After I replaced it, or well, with the Crane electronic ignition, I should say,
Sure.
it never idled very well after that. But it would rev fine, but it never idled. So about 5 years ago, so this is 20 years later, I'm watching one of your YouTube videos, and it was actually about an MGB, and you mentioned the where the pickup should be 45 degrees out of phase with the spark, and my jaw dropped. I said, I think I didn't do that right. And I ran over in the middle of the day, tuned it up, retimed it, and it runs like a brand new car. And it
Hey,
went from a car that I drove a few times a year to one that I drive weekly, if not
nice,
almost daily. So
nice.
that was the one story. The second one was, and you did touch on this after I put the comment, but a couple years ago, maybe after that happened, I started having the engine run hot. It would get up to like 205, even 210.
Hey,
After it was running for a long time, you can probably see where this is going. I checked everything, the radiator, the pump, the hoses, flushed the car, played with different additives, thermostat, and then you were on a, then there was some, can't remember what prompted me to check it, but I was looking at the ignition and I had timed it assuming that the vac it has the vacuum retard on it, and that you're supposed to time to like 2 degrees after top dead center. And at some point, that thing stopped working, and now the car was just running way
yeah.
retarded.
Yep. Yep.
And so I remember you saying, don't mess with that. Just set it to 10 degrees. I think you said, dynamic. I have the car running. It's hot. It's almost overheating. I adjust it. I lock it down. It's all set. And I walk over and look at the gauge, and there it is, right at 190. And I said, and I was just, I couldn't believe that it would have that much effect on it. So I always tell people in the
That
forums
it
and
is.
stuff,
That's timing is just critical.
it is
Everything else
super.
is
I mean, it
art.
was just a tiny. It seems like
Yeah,
a tiny. Of course, the car had a lot more get up and go after that too.
sure, sure.
I actually had one other quick third story because you reminded me of it. Was that long ballast wire that runs in the harness?
Hmm.
I didn't know what that was because they don't show it in the schematic. They just show
Right,
it as a resistor.
right.
So, and I think this was maybe like a year or two ago, and I discovered that all the years with the crane, I had that resistor wire in parallel with the resistor that came with it. So I only had half the resistance that I was
Okay.
supposed to for a 6 volt coil, and I measured it, it was like 10 volts, I think, or 10 and a half volts, and I cut that wire out, dropped it down to I think like 8 or something volts, and it runs the coil doesn't get burning hot anymore when you run the
Yep.
car.
Good. Good.
So,
Good.
but I was like, what is, and I was doing something up in the front with the horns or something. I'm like, what is this? Why would they have a wire come down to the front of the car only to go all the way to the back again?
Yeah.
You know? So those are my three stories, and I
Thanks.
wanted to share them because it was your video that got it working. So
Wonderful. Wonderful. Great.
yep.
Thanks. Larry Smith, should I keep my 1980 MGB 45 DE CEI or go to points? I keep it. Keep it. Carry another one, but go to points. Oh,
I
that's
know.
Mike Cunningham just had a picture there of mm, the other
This
ignition.
this one
That's
here, the
the crane?
Opus. Oh,
No,
the crane. Yes.
it's got the crane because it's got the
I
slot.
think this is after I fixed it.
Yeah, that's after you fix it because it's got the and you where you position that pickup is really important. Yep,
Yes.
yep. All right. Let's see. Ben Andrews, you mentioned straight wires. Did you mean old school wires or just copper core? Yes. When it comes to plug, um, is running an RN9YC resistor plugs on a resistor style wire. Is it losing some spark? No, it's not. Resistor plugs just to help out the AM radio? I think so, but I don't know. That's why the resistor wires are there. So, and then Ron Osbrook says, John, 32 degrees timing at what RPM? Full mechanical advance. You rev it up until the mechanical advance maxes out, till it no longer advances. Then you set the timing. So, all right, let's see. Roadster Factory, we got that. Talk about distributor curves and why are they important? So each engine is designed with a cam. That cam is designed with a distributor curve. It's not a curve, it's two intersecting lines, but they call it a curve. And it's designed. It was designed early on with the distributors of the gasoline that they had and the cams that they put in the car. There's not a lot of other information available about the distributor curves, but they are all over the place. They're sharp, they're flat, they're just all kinds of distributor curves for all different types of cars, for all different types of MGs. Most of it having to do with emissions. So let's see. Um, Steve Leposki, Crane Allison works fine. I have Pertronics as a backup. As long as you can get it in there, it sounds reasonable. As long as you can get it in there, and you can plug the wires onto the coil easily. Best procedure on how to swap them on the road. I don't know if you can swap those easily on the road. And since Steve doesn't have a microphone or video at the moment, all I can do is listen. So I would, if anything, I'd find another Crane Allison, that looks just the same as your original one. And it's hardly ever the pickup inside the distributor that goes bad. It's the transistorized switching unit that's located up on the inner fender. Rob Mance says, I had a spark plug wire fail, infinite resistance, 3 rotors fail in short order before I figured the cable was bad. Is that normal? Well, one leads to the other. Yeah, there's no substitute for checking your spark plug wires with an ohm meter. Absolutely. Talking of timing and overheating, perhaps it's useful to talk about timing and running on. I guess that's tied why the British Leyland fitted anti-run-on valve. No, they did that because the federal requirements in the United States demanded it. That when you turn the key off, car stops dead. They don't want it going bump, 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 because that's spewing unburned hydrocarbons out in the air. So the car will diesel. It will diesel, it will run on, it will diesel if the fuel is still can be combusted. And that's if there's a hot spot in the cylinder head. So if it's been running hot, if you got some stuff growing up in there, some deposits, sharp edges that can nearly incandesce, it'll run like a diesel does, which is you bring enough compression up to it and it'll light up by itself. So the dieseling, what I do on my own MGA, which diesels when I shut it off, that's just the way it is because it's real high compression, is I put it in second gear, depress the clutch, put it in second gear, turn it off, and when I hear it down to about the last couple bumps, I dump the clutch. Ooh, is that bad on the clutch? It's better than the engine going bump, 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 bump. So anyway. How do you check and see if there's a ballast resistor or not? David Halliday. So it depends on the year, but 75 to 79, North American spec, Canada, California federal spec, do have those. I don't know whether the ones in England do. I can't imagine that they do, or the Australian ones. I don't know.
Yeah, John.
Yes.
It's a UK spec car, but it should have a ballast resistor. But when I got it, it's running a 3-ohm coil, and I've kept a 3-ohm coil in it, but it seems to run fine with the 3-ohm coil.
Is the coil powered by a single white or a pair of white with greens?
I think it's powered by a single white, but I'd have to check.
Then that's a 3-ohm coil. If it's a pair of white with greens, then it's a 1.5 ohm coil.
Yeah, the car's been restored, so I don't know if it's the car's very old now, so people have messed with them. So that's
if
why
it's your white wire, generally speaking, is a straight 12 volts, and that should be a 3-ohm coil.
Can I test it with a multimeter to see what
you can test it while it's running? Put the voltmeter from the hot side to ground, and it should be pretty close to 12, 13 volts.
And if it's got a ballast resistor, it should be what about 6 to 8 volts?
6 to 8.
Yeah. Okay.
Okay.
Great. Thank you.
Thanks.
Sorry. If it's got a ballast resistor, then I should have a 1.5 ohm coil in it, shouldn't I?
Yes.
Yeah.
Yes. So Phil asks, he says, I've got a 74B with electronic points. Mechanical advance is not working. I think because it sat for 3 or more years. So if I put if I pull the distributor, it can go back only one way because of the slightly offset dog at the bottom. Yes, that's absolutely right, Phil. But if you take it apart, if you take your distributor apart and free up, you take it all apart. Where did I have this guy. If you take this guy all apart and you take the cam off the top, pop the springs off and take the cam off the top, you can put the cam on backwards. So when you're looking at a distributor, as you're looking at this, the large half is on your right. Is that right? Large half is no. Well, it's on my right. The large half is on my right as I'm taking a look at it underneath it, and the notch is away. The notch in the cam is away, right away. That's what you have to remember when you're reassembling the distributor. That little ditty, right away. Unless the rotor's on, and then it's right on. So, okay, so yeah, if the mechanical advance is not working, it idles great, revs up great, runs like shit on the road. So, here we go. If you want to meter the test capacitance here, Andy Sloman's looking for HVAC meters. Okay, all right, that's cool. Brad Schwartz says the condenser should be about 22 microfarads. Yep, yep. And Dave Densmore says it's called dial back timing light because there's a number on the dial on the back of the timing light to set your desired timing with the light flashing at the 0 mark. Mine is electronic and also does RPM, which is very convenient. Mike Cunningham says, not an endorsement, but they do make remote sense ammeters, so you aren't running all the current through the meter yourself. But if you got a voltmeter, it's a superfluous. Rob, oh, this is good. Here we go. I get a whistle starting at 47 miles an hour in my 1963 MGB. It remains at all speeds above this. It sounds like it's around the driver's side quarter light window. I've taken painter's tape and wrapped wipers, quarter light, hinges, corners. Oh my gosh. Corners of it still whistles. Have you ever experienced this? And what else do I cover to get rid of the noise? In 1980 only, they changed the headlamp rings and had two little scoops so you can adjust the headlights without popping the rim off. But they whistle. Maybe it's your headlight rim. So to get that tape and just start covering more stuff. Rob, I don't know what else to tell you to do. You'll find it. It's got to be there someplace. And if it's at road speed and not RPM related, then it's definitely the wind going around there. So, Larry Smith asks, is the flash guard needed on the 1980 CEI? Was not needed. It's kind of nice to have. It was there. I mean, I don't know if it prevents the spark from jumping to the electronics part of it or not. If you don't have one, you can get another one. I know Sports Car Craftsman in Arvada, Colorado, probably has a box of 1,000 of them used. Pat Coleman, while changing my starter, I noticed the distributor nuts looked loose, put a wrench on them, and they were. I couldn't find a torque for them. How tight should they be? So there's two bolts that hold the distributor clamp into the engine side of the engine, and I'd say those are 15 pounds. It's a 1/4 inch bolt, snug. That's what I'd say. How do we text you? Here, Marty's got my phone number on there. H, horizontal wire exit from cap. Scott, Lynn, thank you very much. From MGA Guru. This is information from Barney Gaylord. That's very cool. Thank you very much. Thank you very much. D stands for distributor. Terry Luft. I put the 4-synchro in Ryan's 1100, working great with 500 miles. Will be at Sandusky. Wonderful. Darren says 73 BGT with HIF carbs runs very well, but when hot, when I stop at a light, sometimes the idle is 1,200, sometimes 1,000, sometimes 700. I never know what I'm going to get. So Darren, there's a couple of things on those carburetors. One is the overrun valves, which you should solder shut. And you should get rid of the lock nuts on the 4 adjuster screws and get AUC 8483 springs. No, AUC 2451 springs to go on so you can adjust all those very, very easily. You don't have a lock nut, which is the way that they came. And the other thing is to deal with the mixture. And the other thing is to make sure that the choke is not coming on automatically, which is really common on the HIFs. So you end up having to take the suction chamber, spring, air piston out, put your finger on the main jet, take the line that goes over the charcoal canister, disconnect that, put a length of tubing on there, and blow so hard you see stars don't use air pressure off the line, just with your mouth. And if you can see gasoline burbling up on the inside throat there, then you need to change those number 13013 O-rings with Viton O-rings. That's a real common problem. Can you talk about distributor curves? Yes. There I did. Yep. Hey, I'm down to the end and it's 9:33. Hey, so I said I'd run till 9:30 and I got all my stuff done. So I'm open for a couple, couple more comments here and there if somebody's got something to add. We're gonna all be in Sandusky. If you're not gonna be in Sandusky, you're not octagonal. Come on, you gotta be there. So, and I don't know when the next Zoom is going to be. Please go to my website, make a donation. Those help out so much. So we're down to 78 people, but I'm wondering, Marty, what kind of count you got tonight?
At 7:51, we had 169 people, but there were 193 people in and out tonight. So
193. What was the max number?
169.
169. Okay. All right. Dynamite. Popular. Not as popular as carburetors. The secrets of SU carburetors. We'll have to do that again pretty soon. That brings in everybody wants to listen to that. So there are
You always forget that there's other factors.
Yeah.
It's vacation time.
Most carburetor problems are distributor problems. It really is the truth. I mean, just what do I do with my distributor? Here. This thing does three things: makes, times, and distributes the spark. It's so important, and it's been running just happily in there. It's so important. It's just as important as the engine and the cam. It's just as important as the carburetors. It's one of the three links in how the engine runs, and it's so often overlooked. If you have any questions about your distributor, send them out and get it rebuilt. Either Medinsky or Schlemmer will do it at British Vacuum Unit in New Hampshire or Advanced Distributor in Minnesota. Don't take it out of the car now. Wait till after the driving season. But my gosh, sometimes it'll transform the way the car runs. So,
hey, John, one comment. I got this from Jeff, the distributor rebuilder.
Yeah.
He said most of the capacitors are good. And if I understand it correctly, when you ground that in the distributor, the path for the electricity has to go through the distributor housing. If you don't pull the distributor out of the engine periodically and clean it, and it either oxidizes or rusted, you get a bad path. And that's part of the problem when he said that we have bad capacitors.
Okay.
Could make sense, could not.
It's certainly possible, but look at the length of the shaft here. Look at the length of that. And some place there's going to make a contact, and it only has to carry 2 amps. So it's only 25 watts.
When he rebuilds a carburetor, he cleans all of that off and makes sure that it's pristine before
absolutely
in the engine. The other thing I read is that
see you next time.
All right, see ya.
The other thing that capacitor creates, it self-induces voltage back into the coil, and that helps drive the secondary voltage up. And if the capacitor goes bad, you get a lower secondary voltage. And I think there was a write-up on Barney Gaylord's site, and he shows how fast or slow that thing develops and decays.
Yeah, it's almost at light speed, So it's
essential in order to get that high voltage spark.
Yes, absolutely
critical. Very good.
Good night, John. Thanks a lot.
Okay, yeah, we're running here at 9:37. So thanks everybody for being here. Vote for Terry Loof for the NAMGBR chairman. Come to Sandusky.
Gloria Cook is up and about with her hair.
John?
Yes.
Where are you going to be on Friday, the 28th? You be in Sandusky or Altoona?
The Friday, the 28th. I'm going to be en route. No, I'll be en route between Sandusky and Altoona.
Okay, that need to be a schizophrenic that can be in one place and the other place at the same time.
How can you be in two places at once when you're not anywhere at all? Yeah.
Yes. Very good. Very good.
Okay. All right. Well, anyway, thank you, everyone, very, very much. It's been a real good time. I brought out all my, I got to get a camera. I got to get a camera and get John and Clark to stand next to me so I can show these things in a little better detail than this little tiny little pinpoint camera in my laptop computer. But it all seems to work. It's all so amazing.
We saw pretty good.
Good. Thanks.
Little shadowy, but
hey,
if you could still see what you were talking about.
Good.
And very much enjoyed this.
All right.
It's good.
All right.
Okay, good night, John. Thank you for everything.
Good night, everyone.
Good night.
Good night. Gallery view, and it said good night, Chet. Good night, David.
Thank you.
Yep. Yep.
Huntley Brinkley.
So Jim Pastor, thanks for hanging on
Good night,
for so
John.
long. Alan Batchelder, nice to see you last weekend. So real pleasure. So
Hey, we
I guess you're not doing the hat thing this week.
My pleasure, John. Nice to see you.
I'm not doing the hat thing this week because my normal counter isn't and I ran out of hats. He's got me beat hands down. He's got more hats than anybody. So
Oh, you
anyway,
just have to go out and buy some more.
yeah, sounds like a good reason. Anyway, thank you.
We
very,
just
very
had some we had some good news. Gloria's after a hip replacement. She went from crutches to a walker. Now she's down to a cane.
And I can get in and out of the MG.
Yeah, that's the most important
Wow.
Yeah, I
can
saw
sit
that
for a few
earlier when you
hours.
got up to walk away.
Yeah,
It looked-
we went to
looked good.
Dayton.
It looked, that's the way
Cleveland.
my wife did hers as well. And
Yeah.
she's getting in and out of my MG with not much of a problem.
Well,
So,
and Gloria was actually underneath the MG today.
no, I haven't gotten that far yet. I haven't gotten her to change oil or anything.
I just bought an MGF for my son, and that's really comfortable. It's like a modern car. It's like a modern car,
You know what? There's on YouTube. I don't know if it's still on. There's the golden age of British sports cars. It's an hour long from the Bug Eye all the way up to XKE. And the one guy said it during the XKE. They all had good things to say about everything, but they said if you can't afford an XKE, buy an MGB. It's comfortable. The windows roll up. It's easy to drive. So
yeah, and people wave at you. Yep.
they do.
Yeah, they do.
We get stopped more and more because you see less and less MGs on the road.
Yep. My daughter just took her 73 BGT from Grand Rapids down to Ann Arbor, so that'll be cool, the tooling around down there. So
Yeah, we went into a fast food place right at the end of COVID down in New Mexico, and they all came to the window. The manager opened the door for us, and the girl behind the counter said, Can I ask you what kind of car that is?" I said, "No." And then she looked shocked. I said, "I'm just kidding." I said, "They stopped making that before you were born." But it's kind of neat when people want to talk to you. Their uncle had one, their brother had one, they had one in college, and it's a lot of fun.
Yep. Yeah, everybody's babysitter's boyfriend's first cousin, second wife had one.
It's like Volkswagens, Beetles. Everybody had a Beetle or knows somebody.
Yep. All right, I'm gonna cut it.
Good night, everyone.
Thank you, John.
Thank
Good
you.
night.
Pleasure.
Thank you, Marty.
Yeah, thank you, Marty. Thanks for being here.
You're welcome.
Good night. Thank you to everyone.
Good night.
Good night.
Oh, let's see. Where's my off switch? Oh,
The older you get, the smaller they get.
yeah. Let's see. Someplace. Of course, it may be that oh, here it is. They're changing this stuff up all the time, and every now and then you lose an important button, but I found it. So good night.
Good night.
All right.
Good night.